In this video, we'll learn about C++ vectors. Suppose we want to store test scores for students in a class, but registration hasn't started yet, so I don't know how many students I'll have in class. Also, students drop and add as the semester progresses. How can I model this information using an array as we've seen to this point? Remember, C++ arrays are fixed in size, and I need to specify a size when I declare them. So what are my options? Well, I can always set the fixed size of the array to a size large enough so that it's unlikely I'll have more than that number of students. Many times this option is okay, but you'll probably make it too big and waste space. For example, we may have 30 students in the class, but we allocated 50 students in the array. Not only have I wasted storage space, but now I need to keep track of how many students are actually in the array. And of course, sooner or later, you'll get that one student that exceeds the size of the array. So what do we do? Well, we can use a dynamic array, such as a vector, to solve some of these problems. A C++ vector is part of the C++ standard template library. This is a library of powerful containers, algorithms, functions, and iterators. This means that we have available to us pre-written, pre-tested, easy-to-use components that we can use to help us solve our problems. We'll go over the main components of the standard template library toward the end of this course. We've talked about C++ being an object-oriented language. Well, when we create a C++ vector, we are creating a C++ object, and we can ask the object to perform operations for us. Vectors can grow and shrink in size at runtime, so it's a perfect choice to model my students. Vectors also provide syntax and semantics similar to arrays, so now that we've learned about arrays, understanding vectors will be pretty easy. In addition to the array-like syntax, we can also use lots of really powerful functions like sort, reverse, erase, find, and more. Vectors also give us the ability to use methods that provide bounds checking if we wish. Let's see how we can declare vectors. There are several ways to declare a vector. The syntax for declaring a vector changes slightly from that of declaring an array because vectors are objects. First, we must include the vector library. Also, the vector type is part of the standard library, so we must either use the namespace or use standard and the scope resolution operator. We can create a vector of any type we want, just like we did with arrays. Here's the syntax for vectors. Don't worry at this point what the differences are. We'll cover this in a future section. Since the vector is an object-oriented template class, we must include the type of the elements of the vector inside the angle brackets. So for example, vowels is a vector or a collection of characters. Test scores is a vector of integers. Both these examples create an empty vector that contains no elements. Let's look at a few other ways to declare vectors. In the first example, we declare vowels to be a vector containing 5 characters. In this case, I'm not providing an initializer list. We'll do that in the next slide. Instead, I'm using a constructor initialization syntax which provides information inside parentheses. This tells the compiler that you want 5 characters. In the second example, we declare a vector named test scores of 10 integers. Unlike arrays, these 10 integers will be automatically set to 0. I don't have to do that explicitly myself. We can also use initializer lists as we did with arrays to initialize vector elements. In this first example, we declare vowels to be a vector containing 5 characters. In the first example, we declare and initialize the vowels vector to the characters A, E, I, O, U. Note that there are single quotes around the character literals, not double quotes. In the second example, we declare and initialize a vector named test scores to the integers 100, 98, 89, 85, and 93. In the third example, notice that there are 2 values in the parentheses. The first value, a parameter, is the initial size of the vector, in this case 365. The second value is what you want to initialize all the 365 doubles to. In this case, we're declaring a vector of 365 doubles, and we're initializing all of those doubles to 80.0 degrees Fahrenheit. There are also many other ways to declare vectors. You can declare a vector to be a copy of an array or a copy of another vector. I think you're beginning to see how powerful vectors can be compared to arrays. So let's do a quick recap about vectors. We learned that vectors are an object-oriented container defined in the standard template library. We must include the vector include file to use them, and they belong to the standard namespace. Like arrays, vectors allow you to tell the compiler to give you a collection of as many elements as you want and give the entire collection a single name. Vectors are dynamic in size, which means they can grow and shrink as needed at runtime. Like arrays, vector data is stored contiguously in memory. Vector elements are individually accessible. Vector indexes start at 0 and end at position size -1. If you use the subscript operator, that's the square brackets, to access vector elements, then vectors will provide no bounds checking. This provides the same behavior as arrays. However, vectors provide a rich set of functions that do provide type checking. As a programmer, you can decide what you need to use. Unlike arrays, when you declare a vector, the vector elements will automatically be initialized to 0 unless you specify otherwise. So if you declare a vector of 10 integers, these integers will be initialized to 0. They won't contain garbage. Vectors are very efficient. And finally, we commonly use iteration or looping to process vectors just like we do in arrays. Later in this section, we'll talk about C++ vectors. In the next video, we'll look at how we can access individual vector elements, and we'll also see a few of those useful vector functions I mentioned.